Hello guys, we want to discuss terrestrial telescope. And terrestrial telescope is like astronomical telescope in the sense that why did I say they are like astronomical telescope? The only difference between this one and astronomical telescope is that there is an additional lenses that is added, or there is an additional lens that is added, which we call the inverting lens. It is what? Designed basically for what? For viewing what? Objects on the what? On the earth. And how many lenses they use what? It uses what? Three what? Lenses. Three lenses. Three, well, let me put it this way. Three convex lenses. So that means an additional one. So the difference between this one and astronomical telescope is that it uses three convex lenses. Astronomical telescope uses what? Two convex lenses. Now I will tell you the reason why we introduced the third one. Now to achieve something here. Now the image, the objective lens is what? The objective lens has a what? A long what? Focal length. And then the eyepiece lens has what? A short what? Focal length. So that means that in this case now, how do we make the arrangement? How do we draw the arrangement of this instrument? Let me show us, because it's very important we see the diagram of this telescope so that if I'm explaining, you'll be getting it. Now the image, you have what? The image is coming from infinity. It's coming from infinity. And it will now what? Meets at what? They will meet at what? At the focal points or the principal focus better of the what? The objective lens. Now they will meet at the principal focus of the objective lens. Now what I'm going to do now simply is to what? To arrange the third lens to be at a distance of what? Of 2f. Two focal lengths. That means the focal length of the middle lens should be at what? 2f. Now let's arrange it. Now the length here from here to here should be 2f. So that if it is 2f, now the image will now be what? Look at what will happen. It will produce the same thing, the same image, but this time around we erect it. So that means from here to this place is 2f. Sorry, it's 2f, not 2f not. 2f. So this one has the focal length of f. This is a focal length of f naught. While the focal length of the last one. Now, this last one, which is your eyepiece lens, will now be arranged to be at what? At f naught from here. Fa from this place to this place. So that the image now, you can send the image to what? To infinity. So when you send the image to infinity, you have something like this. Now, having gotten that, so this is the diagram we are going to have. So we have the third what? Lens and the middle, which you call the what? the inverting lens. This one is what we call the what? The objective lens. Why this one is called the what? The eyepiece lens. Now, the issue here is that the length from here to here is f naught, which is where the image is formed. So the image here is real, inverted, and diminished. They ask you in the exam, what is the image formed by the what? Objective lens in a terrestrial telescope? It is real, inverted, and diminished. What about the image formed by the erecting lens? It is what? Same size as the what? This image. The image formed here is same size as this one. That's why if you check, the distance from here to here is 2f, the distance from here is 2f. So this point is like the center, the optical center, or the center of what? Of curvature, as the case may be. So in this case now, this point is what? The optical center of the eyepiece lens. This is optical center of the erect. We can call it either erecting lenses or erecting lens or inverting lens, anyone they call it. Why? What it does is to erect the image for us. Now, so the final image now is what? What is the final image? The final image of a terrestrial what? Telescope is virtual, erect, and what? Magnify. Virtual, erect, and magnify. And don't forget that they are suitable for what? For a particular telescope. Although they are too bulky, they are big in the sense that for you to carry them along, because of, look at it, they have 3 lenses now. So the additional lens here is what? The erecting lenses. So in this case now, if you want to calculate the length, now let me go there first before I'll come back to you. The length is what? From here to here is f naught plus 2f plus 2f is 4f plus f naught from here to this place is f naught. That means fe rather. From here is objective eyepiece length focal length. From here to here is what? Here to this place is what? 2f. From here to this place is f. So in that case, it is this is the length of this particular what? Of this particular lens. Now, if they ask what by how many is the length of a terrestrial telescope increased compared to what? The astronomical telescope. It increases by what? It increases by 4f. Please take note of that. It increases by 4f. So astronomical telescope and terrestrial telescope, the difference between the two length between the lenses is just 4f. And this one is brought in by what? Erecting lens, to erect the image so that the image will be virtual, erect, and what? Magnify. And it is formed at what? At what? Infinity. At infinity. The image is at what? Infinity. So if the image is at infinity, it produces virtual, erect, and magnify. So I've told you that the difference between, because we check an astronomical telescope, go and watch the video, is f naught plus fe that I gave you. That means the length between the two lenses. But here they have 3 lenses, and what brought about the increase in length? So that means this one have a longer length compared to what? Astronomical telescope and even what? Galilean telescope. So please take note of that. Now another thing again is that it what? Produce what? That means its product, sorry, let me explain something here before I go to this part. Now In a terrestrial telescope, we have explained the image that is virtual, erect, and magnified. Now, the problem students will always ask, the question students will always ask is that what is the advantages and disadvantage of this? Or what is the magnification? It is very difficult for us to calculate the magnification because it is cumbersome, it is big for us to carry all along. So, and because of this one, it is very difficult for us to calculate the magnification. So in that case now, because we are introducing another lens, indirectly this image, the image produced at infinity is also what? With the help of this, and that makes it what? Virtual, erect, and magnified. But before I leave this studio, let me show you something here. Let me show you something. Now, if we want to look at the three lenses now, this and this, which one has a higher focal length? Objective lens and eyepiece lens, which one have a objective lens has a greater focal length than eyepiece lens. Number two is that what makes an image, the image to be what? Virtual, erect, and magnified. Which lenses? What is the name of the lens that made the image, the final image formed by terrestrial telescope to be virtual, erect, and magnified? We said what? An inverting lens, or what we call what? Sometimes we can use prism. Sometimes we can use prism to do that. So please take note of that. Prism can be used instead of what? But we can also call it what they call erecting what? Lenses. So the only assignment I want to give us here, let me give you an assignment because I don't want to waste too much time here. Now is that what are the advantages of this what? Lens, terrestrial telescope. And what are the what? The disadvantages of this lens. So what I want you to do now is type your answer in the comment section so that in the next class we will explain the advantage and disadvantage, linking it up with what we call prism binocular. We are going to talk about prism binocular in our next class. So how prism binocular resolve the issue or the disadvantage of the terrestrial telescope. How does it resolve it? We are going to see in our next class. Thank you. God bless you.